Okay, hello and welcome back to this section of HUP 112, Logic and Philosophy. My name is Dr. Richard Brown. So we're going to be looking at what are called rules of implication. And rules of implication consist of valid argument forms, which have now been turned into rules by which we can prove the other arguments that we're interested in. There's going to be quite a few of these, and we're going to build up every week talking about more and more of them. So today we're going to introduce the first four and their abbreviations. So the first one is Modus Ponens, the second one is Modus Tollens, the third one is what we're going to call pure hypothetical syllogism, and then the fourth one is what we're going to call disjunctive syllogism. Modus Ponens, which says if P then Q, P, so therefore Q. Modus Tollens, which says if P then Q, not Q, so not P. Hypothetical syllogism, which says if P then Q, and if Q then R, then P then R. And then over here we have a disjunctive syllogism, which is P or Q, not P, therefore Q. Now, these come, remember, we know these are valid. We can prove that they're valid using the truth tables that we've done before. And if we were to look at the truth tables for any one of these, we would see that it would be impossible for us to construct a line of a truth table where the premises of these arguments are true and the conclusion of these arguments are false. Another way to put that is if we make a conditional statement taking the premises as a conjunction, horseshoe to the conclusion, then we end up with something that's a tautology. So the associated conditional here would be if you have P horseshoe Q, and if you also have P then Q. This will come out to be a tautology if you do the truth table. And the same would be true here. If you have P horseshoe Q and not Q, then you get not P. That will also be a tautology. And the same is true here in each case. So let's just, for the sake of illustration, take our pure hypothetical syllogism. So this says if you have P horseshoe to Q, and if you have Q horseshoe to R, then you have P horseshoe to R. P horseshoe to R. Okay, so there's our associated conditional right there. Here's the first premise, and we've just conjoined it, saying and, to the second premise, and now we've said that that implies this thing right here, which is the conclusion. So let's quickly do a truth table for this, and we know from our previous discussion that the amount of lines on your truth table is going to depend on how many propositions are in the premises and the conclusion. And here we have P, Q, and R. We have P, Q, and R, so that's three different propositions, and our formula tells us that we have 2 to the n lines here, and so what we have is 2 to the 3, and that's going to be 8 lines. So that should be old hat, but we will now construct those 8 lines, and the way that we do it, again, take the number you divide in half, and you start the first one even numbers of true and false. So we write 4 truths and 4 falses. We have 4 truths and 4 falses. And here we take that number and halve it again. So we write 2 truths, 2 falses. Repeat, 2 truths, 2 falses. Q, wherever we find that, we write that same thing. 2 truths, 2 falses, 2 truths, 2 falses. R, now this last one, we simply alternate true, false, true, false, true, false, true, false. And where we find the same thing, we write the same thing. So 4, 1, 2, 3, 4, 1, 2, 3, 4, and R, we alternate true, false, true, false, true, false, true, false. So now we've written these out. Let's draw some lines in here. just so that we don't make any mistakes. And of course, one of the nice things about using Applia is that these grids are provided for you and you don't have to worry about drawing these things out by hand like this. Okay, so now we've mapped this out. Now we simply compute the truth values. And so we'll start in here and we'll simply compute them. True and true tells us true. True and true is true. True and false is false. True and false is false. False and true is true. False and true, true. False and true. Excuse me, false and false, still true. False and false, still true. So now we've computed the truth values for P horseshoe Q. Now we'll compute the truth values for Q horseshoe R, right here. So true and true is true. True and false is false. False and true is true. False and false is true. True and true is true. True and false. 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 False and true. True. False and false. True. Okay, so now we've computed the truth values for that horseshoe. We may as well just come over here and compute the truth values for this one. We could go back and do the dot. We'll do that next. But while we're here, we'll just do this. So true and true is true. True and false is false. True and true is true. True and false is false. And these ones are all false. And so we know from the rule that when the antecedent of a conditional statement is false, then no matter what's on the other side, you get true. So there we go. Now we have that. Now we can compute the AND statement here using what we got from our two conditionals. So we have true and true with AND, that's true. True and false, that's false with AND. False and true, that's false with AND. False and true, that's false with AND. True and true, that's true with AND. True and false, that's false with AND. True and true is true. True and true is true. So now we have that, and we have our conclusion here, and now we'll compute this conditional, the main operator, using this conjunctive statement and this conditional statement. So we have true and true with the horseshoe is true. We have false, and false with the horseshoe is true. We have false and true with the horseshoe. False and false with the horseshoe. True and true with the horseshoe. False and true. True and true. True and true. And we can see that the resulting truth table here is a tautology. So the pure hypothetical syllogism will never allow you to have true premises and a false conclusion. You can simply look here and see where the premises are true, the conclusion is true. Okay. Premises are true, the conclusion is true. If you have one of the if you have the conclusion turning out to be false, as you do right here, then you have one of the premises also turning out to be false. So that you get a tautology here, and now we know that we can use this in other arguments when we're thinking about them and get a very nice result. So let's go ahead and use our four rules then: Modus Tollens, Modus Ponens, disjunctive syllogism, and pure hypothetical syllogism to derive some of these things. So I'm going to use an example from the book here, and we'll take one of these word problems here. Okay, so this comes from the book. It says the instructions are to translate the following arguments, because remember, we always want to be practicing translations. So translate the following arguments into symbolic form and use the first four rules of inference to derive the conclusion of each. And they give us the letters. So let me read you the first argument here. It says, if the average child watches more than 5 hours of television per day, then either his power of imagination is improved or he becomes conditioned to expect constant excitement. The average child's power of imagination is not improved by watching television. Also, the average child does watch more than 5 hours of television per day. Therefore, the average child is conditioned to expect constant excitement. Now, right off the bat, what you want to do is identify the premises and the conclusion. And here, the indicator is the word therefore. It tells us that the conclusion is the average child is conditioned to expect constant excitement. So I'm going to use C to stand for that sentence. Okay, so that's our conclusion. Now, the first sentence here, let's go back to that. The first sentence says, if the average child watches more than 5 hours of television per day, then either his power of imagination is improved or he becomes conditioned. So let's see here. We will use W to stand for the average child watches more than 5 hours. So, and we will use P to say that their powers of imagination is improved. Okay, so we have our C, W, and P here, and now we can look back at the what we'll call the first premise and translate it. It says, if the average child watches more than 5 hours of television per day, then either his power of imagination is improved or he becomes conditioned to expect constant excitement. So we'll use W. If the average child watches more than 5 hours of TV per day, then either, okay, his power of imagination is improved, or he becomes conditioned to expect constant excitement. So that first premise will say W horseshoe, open parentheses, P wedge C, close parentheses. So we translate that there. And let's see what the second sentence here, it says the average child's power of imagination is not improved by watching television. So that's, we're using P, so that would be tilde P. It's not improved, the power of imagination. Also, the average child does watch more than 5 hours of TV per day, so we'll include that as a separate premise, that they do in fact watch more than 5 hours of TV per day. Therefore, the average child is conditioned, so that's our conclusion. Therefore, the average child is conditioned to expect constant excitement. So this is the argument that we're presented with. We've taken it from the English and translated it into our propositional logic. And now we have our 4 rules: Modus Ponens, Modus Tollens, hypothetical syllogism, and disjunctive syllogism. And what we want to do is to find this conclusion in these premises and to show that it follows by an application of these rules. So we see that the conclusion is C, and we see C is right there. It's attached by this wedge to P. So we have a wedge rule, and that's disjunctive syllogism, which tells us if you know P, wedge Q, and if you have tilde P, then you can get Q. So we have C here, and we have P. If we had tilde P, we could use disjunctive syllogism and get the C. So there's a tilde P right there. So that's nice. That's something we want to pay attention to, that we have the tilde P right there. Okay. But we have to get this on a line by itself. We cannot use tilde P and apply disjunctive syllogism right there because it's part of this larger sentence. W, horseshoe, parentheses, P wedge C. But of course, we could use modus ponens to get P wedge C if we had W hanging around. And we know that W because we've asserted W on line 3. So now we can see a way to get the conclusion from these premises. So let's go ahead and apply that. So we would write a new line, which means that we're asserting something, and we're going to assert P wedge C. Why do we get to write that? Well, because lines 1 and 3 together make a modus ponens. And modus ponens says if you have a certain letters horseshoe together and the antecedent is asserted on a line, then you can derive the consequent, and that's what we've done. So now we have P wedge C here, and line 2 is tilde P, so we can use our disjunctive syllogism rule. Like line 5 concludes C, and we did that because lines 2 and 4 are disjunctive syllogism. And now we're done because we've derived the conclusion, the thing that we wanted to, using the rules. So we've proved that this argument is valid. We've proved that this argument is valid using our 4 rules. Okay, so let's do another one, and let's make this one a slightly more complicated one. Again, this one's coming from the book. So The following argument is question number 10 from the section we're working on. And it says the following thing. So it says, if the death penalty is not cruel and unusual punishment, then either it is cruel and unusual punishment, or if society is justified in using it, then it will deter other criminals. That's quite a sentence. Second sentence, if the death penalty is cruel and unusual punishment, then it is both cruel and unusual, and its use degrades society as a whole. Okay. It is not the case that both the death penalty is cruel and unusual, and its use degrades society as a whole. Furthermore, the death penalty will not deter other criminals. Therefore, society is not justified in using the death penalty. So the conclusion there is clearly, therefore, society is not justified in using the death penalty. And one of the things that we should recognize right off the bat is that we would not use a sentence J to stand for not justified. So we want to use the sentence J to stand for society is justified in using the death penalty, and then we would get a tilde on that to represent what the sentence says, that it's not justified. So we have our letters that we're going to use here, and we can use any ones we want, but the book has given us C, J, D, and U. C, J, D, and U. So let's see where these fit in here. So the first sentence says, if the death penalty is not cruel and unusual punishment, so we'll use death penalty as cruel and unusual punishment, then either it is cruel and unusual punishment, or if society is justified, we'll use J to stand for society is justified in using it, then it will deter other criminals. If the death penalty is cruel and unusual punishment, then it is both cruel and unusual, and its use degrades society as a whole. So now we have our C, J, D, and U, so let's go through and translate these sentences. So let's go ahead and work our way through this and see what we can do here. Okay. So we have C here. So we always start by writing another line on the proof here, and you can see that we have C horseshoe C dot U here, and we have tilde C dot U here. So those two together make a modus ponens. If this is P and that is Q, then this says tilde Q. So we can write tilde C right here, and we can write tilde C because lines 2 and 3 make a modus tollens. 2 and 3 make a modus tollens. So now we have tilde C here, but now that's very nice because see, now we can use lines 1 and lines 5 and get this thing over here on the end. So we can write line 6 right here, and what we'll derive is C wedge J horseshoe D. And we got that because lines 1 and 5 are modus ponens. 1 and 5 are modus ponens. So now we have tilde C, and we have C wedge this thing. So now what we can do is use our disjunctive syllogism rule, which says if you have P wedge Q and tilde P, then you get the Q term. So we can write line 7, and that's J horseshoe D, and we got that from lines 5 and line 6, and that was disjunctive syllogism. And now we're done. We have tilde D on line 4, we have J horseshoe D on line 7, so we can write line 8, tilde J, and we can say that we got that because lines 4 and 7 are modus tollens. So now notice, this we wrote 1, 2, 3, 4 lines given what was already there, plus 4 lines, and we were able to show that in fact this conclusion does follow validly from these premises. And we could have shown the exact same thing using a truth table, but it would have taken us 16 lines and lots of truths and falses everywhere, and this seems like a much more natural way of showing how the conclusion is derivable or implied by these premises. Now, of course, what we've just shown is that if you accept every one of these things as true, then you must accept this because it implies logically that. Now, of course, does that mean that this is true? No, it depends on whether these things written up here are true. And some of them may not be true. So we'll just finish up talking about this dialogue that's in the book called Romance with an Android. And we'll go through some of these dialogues, and we'll try to symbolize the arguments that are in there and use the rules to show whether the arguments are valid. So this is says two people talking. One says, I just came from Professor Shaw's class on the philosophy of human nature. Nick says to his friend Aaron as he meets her in the hallway. We discussed the question of whether an android could be a person and whether we would ever consider going out on a date with an android, assuming it looked just like an attractive human. Sounds like an interesting class, Aaron replies, but an android can never be a person. Okay, why is that, Nick asks. It's really quite simple, she says. If an android is a person, then it's rational, but no android is rational, so it's not a person. Now notice, there's an argument there. The word so is a conclusion indicator, and what Aaron is trying to establish is that androids aren't persons. So let's go ahead and symbolize this argument. She says, if an android is a person, then it's rational. So we'll use A to stand for an android is a person, and R to stand for the android is rational. So her first premise says A horseshoe R. Her second premise is that no android is rational, and the conclusion is that no android is a person. Excuse me. Let's use P up here. For android is a person, then the android is rational, but it's not rational, so therefore it's not P. And you can see just by looking at this that it looks like a version of Modus Ponens will get us the conclusion. So 1 and 2, here's tilde R, here's P horseshoe R, and we're allowed to write tilde P because 1 and 2 make Modus Ponens, and then that proves the conclusion here. Now notice that this means that the argument is in fact valid, that if you accept the premises, then the conclusion follows. But notice what Nick says in the very next passage. He says, but wait, Nick says, androids can solve problems and they can also deliberate, and if they can either deliberate or solve problems in the rational right, so androids are rational after all. Now there's an argument there, but notice what the argument, before we start symbolizing the argument and talking about it, notice what Nick is trying to do here. He's trying to attack this second premise, that androids are not rational. It looks like he pretty much agrees with Aaron on the first premise, that if androids are persons, then they're rational. But Aaron says, well, no androids are rational. But Alex is attacking that, and he's giving a separate argument that this is false. And that's an important kind of point that's being illustrated here, I think, is that the way that philosophy is actually done often by philosophers is that they will formulate an argument. The argument will be valid. And so what that means is if you accept the premises, then the conclusion follows. But the premises may not be true. So you start to examine whether or not you accept the premises or not. And it certainly looks like Nick doesn't accept this second premise. He wants to show that there's good reason for accepting that androids are in fact rational. So let's see what he says. He says androids can solve problems and they can also deliberate. So androids, androids can solve problems and they can also deliberate. And the third premise says, and if they can either deliberate or solve problems, D wedge S, if they can do that, then they're rational. So the conclusion is that they're rational after all. So the conclusion here would be that they're rational after all. Now, notice that this looks like it should be a valid argument, but we don't have the rules here for doing this.